Hey guys, I just wanted to go over these ranking tasks with you, just as far as what type of question this is. And we're going to do this first one together. And then you have the back side of this worksheet to do on your own. And this is something that we're going to do with each unit. So we're going to introduce it now. So a ranking task is really geared towards objects, or not objects, but applying concepts over math. So we're not going to necessarily go through and calculate a bunch of things. We're going to basically kind of talk our way through the physics. We're going to rely on vocabulary or laws or rules or relationships between variables, and not necessarily plugging in some numbers and getting an answer. So I'm going to go ahead and exit out of my face, and then we're going to look at this task together. So the first one are motion diagrams, and we're going to rank based on both displacement and velocity. So flash strobe photographs were taken every second of a set of spheres moving from left to right. So what we're saying here is that each of these images, each dot represents 1 second. The diagram shows the location of each sphere where the photograph was taken. So we see that location we're measuring in meters. The total time intervals shown vary, right? There's only 4 here, whereas there's more on others. All the displacements are in meters. So let's look at what and how we're going to rank. So the first thing we're asked to do is to rank them based on their greatest displacement over the first 3 seconds. So it is giving us a specific time interval. If each ball represents a picture taken 1 second, then we're going to be looking 3 seconds in and not at the entire thing. Give the highest rank to the one with the greatest displacement, and give the lowest rank to the one indicating the least displacement. If the motion diagram indicate the same displacement for the 3-second interval, we'll give them the same rank. So let's go ahead and, so let's identify those 3-second intervals. So we're going to go ahead and I'm going to circle them. I want to know what I'm looking for. So we have 1 second, 2 seconds, 3 seconds. So really we're looking for the 4th snapshot. The first one is the initial. And we see that it starts at 0. So I have from 0, 1, 2, 3 seconds. And then C also starts at 0, 1, 2, 3 seconds here. D, 1, 2, all the way over here in 3. And E, 1, 2, 3. And then F actually starts over here at 1, and we go 1, 2, and 3. So we're asked only to base our ranking on the displacement. So we're only looking at how far along the number line they've moved. We're not looking at fast or slow, speeding up or slowing down, simply displacement. So we go and we look at our objects, and at first glance, I might think that F is the greatest, right? It's at 10. But it also started at 1. So the displacement here is 9, right? 1 to 10. And then I might notice that on D, I have the same displacement. I'm going from 0 to 9. So again, we have a displacement of 9. So I have D and F that are the same. So when I do my ranking, I do the equal or greater than. So I might say D is equal to F. Then I just work my way back. So I had 9. The next highest would be 7, so greater than E, which is greater than A at 6, greater than B at 4, which is greater than C at 2. So we just work our way back. So that would be our ranking for the first one, and we're asked to explain why. So using vocabulary terms, we might include the definition of displacement, which is that it is the greatest distance from where it starts to where it ends, so starting point to ending point. We might mention that displacement is just a measure along the axis. It doesn't include fast or slow, and that part wasn't included in the question. And all traveled for the same time interval. So we weren't looking at how quickly they got to 10 or how fast they were going at 3, just how far after 3 seconds. The next thing, and I'm not going to scroll just for the sake of the drawings. But the next thing it asked us to rank was based on velocity. So same setup though, right? We're still looking at a time interval of 3 seconds. And it asks us to rank based on velocity. So it's giving me time. I know meters. So what I have is a time and a distance. So I have t and I know delta x. And I'm asked about velocity. So we know that velocity is equal to delta x, this is so ugly, over t. So for this one, the time interval is the same, right? No matter what I do, I'm still only looking at 3 seconds. So this is a constant, which means that in order to figure out which one is moving the fastest or has the greatest velocity, I only need to look at the displacement. Whichever one covered more ground or had a greater displacement after 3 seconds had to have been going the fastest. So the ranking is actually the same as it was for displacement. And our explanation would include this idea again that time is constant. This is our equation for velocity. And so if time is constant, then our variable is delta x. And we had used that in our earlier ranking. So that's a ranking task. This will be your example. You're going to look at the bottom one on your own. Let's see if this lets me. All right, so here's the second one. This is one you're going to answer on your own. There is an assignment on Canvas. You can either submit a picture of your task in your notebook, or you can just type your answer, whichever you'd rather do, whichever's easier for you. But here, we're going to look, at velocity and acceleration. So the setup is that the following drawings indicate the motion of a ball. Subject, let me start over. Subject to one or more forces on various surfaces from left to right. So just telling you that different things are making them move. Each circle represents the position of the ball at succeeding instants of time. Each time interval between successive positions is equal. So again, meaning that this was 1 second, 1 second, 1 second, 1, 1, 1, 1, 1. Similar to what we just saw before. So you're going to rank them from highest to lowest velocity, so from fastest to slowest. Again, you see the arrow pointing in the direction of motion, so either positive or negative. 0 is greater than negative, and then you're going to rank them then based on highest to lowest acceleration. So which ones are speeding up, slowing down, or constant. Again, note that 0 is greater than negative, and you can tie. So I want you to try this one. Again, you're going to try the rank, and then you're going to give your explanation, and then we'll talk about these when we are together in class next.